All right, welcome back, everybody. This is episode 21 of my multi-cloud network architecture series. And in this episode, we're talking about fully qualified domain name filtering, FQDN filtering. We're going to go over what FQDN filtering is, how Aviatrix offers an enterprise class FQDN filtering solution, how to design FQDN filtering for the multi-cloud, and lastly, how you deploy the solution through the Aviatrix multi-cloud networking platform. Let's get started. So what is FQDN filtering? We got to start with the problem. An important security measure for your VPCs and VNets is to effectively control outbound network traffic towards the internet, egress traffic, delineating legitimate from illegitimate requests. So if an internal user or a cloud instance was compromised, they could pose a significant threat if the attackers are able to exfiltrate data. Many compliance frameworks like PCI DSS and HIPAA require egress security controls. That said, there's a lot of reasons why cloud users or instances within VPCs or VNets need to access the internet. The reasons range from getting basic software updates from Microsoft, Google, or Ubuntu to needing application access to other third-party or SaaS services over the internet. For example, you might have an application that's leveraging API calls to a SaaS service or a third-party app. If you have more than a handful of VPCs, management of whitelists on a per VPC or VNet basis can become a major source of pain. Also, it can be cost prohibitive to deploy next generation firewall solutions per VPC to solve this problem. What's really needed is a centrally managed, scalable, and cost-effective solution. Enter Aviatrix. The Aviatrix FQDN filtering solution provides inline Aviatrix gateways with egress firewall functions in each VPC or VNet, but with centralized management of policies in the Aviatrix controller. It blocks all outbound internet traffic except specific whitelisted domain names, FQDNs. This solution directs the outbound traffic through the Aviatrix filtering and monitoring instance on a per VPC or VNet basis. The inline gateways are actually highly available as well, and they're designed to leverage availability zones and automatic failover. The controller handles all of that for you. It handles the insertion of these gateways, the routing of traffic towards the gateways, as well as all the high availability mechanisms involved with the gateways. The controller provides CloudOps teams with centralized policy management, from the ability to tag VPCs and assign policies to tags. The controller also provides centralized audit logs. The controller can also enable discovery. So if you're not sure what your instances or hosts are trying to access, you can enable discovery on the controller and it will tell you exactly what you're trying to access. Then you can build your policies based off of that. Finally, using the Aviatrix CloudFormation templates or Terraform, CloudOps teams can automate the deployment of VPC or VNet egress security with any new VPC or VNet that enters the environment. The next question is, what makes the Aviatrix solution different from everything else on the market? What makes our solution truly enterprise class? This chart right here on the screen says it all. So you can pause the video now and review it at your own pace, but I want to draw attention to two important things on this chart. Number one, Aviatrix supports additional protocols, more than just HTTP and HTTPS. We can filter based off of SFTP, FTP, ICMP, and others. Squid does not have this functionality. AWS NAT Gateway does not have this functionality. Enterprises have been begging for this functionality and we have it built in day one. Number two, centralized management console. Everything you build and configure and manage and monitor is done through the Aviatrix centralized console, centralized UI. It's a really elegant UI with guardrails. Anybody can figure it out. Very intuitive, but fully functional. One place to do everything. Squid does not have this functionality. Now you have to go VPC or VNet by VNet and manage every instance separately. Does not scale. Everybody hates that. AWS has an AWS console to deploy the AWS NAT Gateway, but their solution for FQDN filtering is so basic, it really does not have any functionality for an enterprise organization. So most enterprises are not even considering that. Here are some of the key benefits of the Aviatrix solution. Now, I'm not going to read through all of this. You can pause the video and read through it at your own pace, but I want to draw attention to a couple important pieces. Number one, this whole platform is cloud native, meaning it understands all the cloud constructs, the route tables, the subnets, the route entries, the ingress and egress points. It knows how to configure all that for you. And so it's beautiful in a way that you can go into the UI or use Terraform to deploy your FQDN egress gateways in your VPCs and VNets, and the Aviatrix controller handles all the routing, all the HA, all the availability zone components, pretty much anything that has to do with the native cloud piece, the controller handles it for you, including the deployment and management of those gateways. Really, it's one touch. Another cool feature is the FQDN discovery. So if you don't know what your apps or your instances are accessing on the internet and you want to audit that and get an idea of what they're accessing, you can enable discovery on an egress gateway, and it will begin to collect a report of every FQDN that's being called on. Really handy for you to build your policies. So let's jump right into configuring the Aviatrix FQDN filtering solution. Now there's a couple ways to deploy it. The most common way is a decentralized FQDN egress model. What that means is you place the Aviatrix FQDN gateways in every single VPC or VNet that you have deployed that needs this functionality. You might think this is expensive, but actually it's not. These gateways can be relatively small sized instances. So this is what we're going to do in the demo today. We're going to build this out. Now there's an alternative approach that provides a lot more features and functionality because it starts to leverage the entire Aviatrix networking platform from a transit perspective. That's called centralized FQDN. So if I click that here, you can see that in this scenario, we set up a centralized VPC with transit gateways, and then the transit gateways connect to individual FQDN gateway instances. Our workload VPCs send their internet-bound traffic through a spoke gateway to hit the transit gateway, and then the transit gateway will hash it and send that traffic to an appropriate FQDN gateway. Now this is great because you get to use all the benefits of the Aviatrix platform, the visibility, the automation, the high performance encryption and routing automation built into the controller. But then you also get to leverage the firewall deployment model, but instead of deploying a firewall, you deploy the FQDN gateways as if they were a firewall. So it's the same function, the same workflow in our UI to deploy firewalls in a transit network as it is to deploy FQDN gateways that scale out horizontally. You can get high throughput, high availability with this model. Now I've gone through on how to deploy firewalls using the Aviatrix firewall workflow in many of my videos. So go check out the Aviatrix YouTube channel or Dana at Aviatrix YouTube channel and you'll find a lot of demos on that. Let's get started on the decentralized model. Alright, so I've already built out this VPC and put a jump host in there in a public subnet as well as a workload VM in a private subnet. And this workload VM is what we're going to give access to the internet to through the FQDN gateways, but we're going to place a policy on them so it can only access certain things. It's as simple as going to the Aviatrix controller and deploying a gateway in that VPC. So you go to gateway, click create new. We're going to select the cloud type. Of course, we're doing this in AWS today, but this could be done in GCP, in Azure, Oracle, etc. Let's give it a name, FQDN GW. And I'm going to select it in this region. And I know I've called it the test FQDN VPC. That's the name of the VPC. Now I have a bunch of public subnets in there. It doesn't matter which one I pick. Let's just pick 1A. All right. And we can leave the gateway size at T2 micro. It's fine for now. All right. That's all we need. Right, we're going to disable this. We don't need VPN access enabled. We're going to hit create. As simple as that, we're done deploying that gateway. Now remember, we want to make this HA, so we're going to deploy a second one now. To do that, go find the gateway you just deployed. Here it is. And we're going to edit it. And we're going to do gateway for high availability peering. So let's create a second one and put it into a different availability zone. Let's just throw it into 1B. Hit create. Okay, same process, but this time it's making it HA, meaning it knows where to place that gateway, what route tables to program to point towards that gateway to make it HA so that traffic is load balanced across both gateways. If one gateway goes down, the controller recognizes that and reprograms the routes in the routing table for those subnets and points it at the available gateway. So automatic HA for you. Okay, and it's done deploying the high availability gateway. Okay, next I want to review the AWS routing really quickly. Under the subnet section, I'm going to search for my FQDN subnets. Here I've pre-built a bunch of subnets, a bunch of public and a bunch of private ones. I think there are just a bunch of /20s. But what you can see here is that the public subnets have default route to the local IGW, so it can reach the internet. And also the private subnets do not have that. So they're private, right? There's no access to the internet there. My workload resides in one of these privates. So right now it doesn't have access to the internet. Now the controller is smart enough. When it inserts the gateways in line into the path of traffic, it knows not to reprogram route tables that have a route to an IGW because it doesn't want to mess up your existing connectivity. But if there's no IGW, it will put a route to the internet towards the gateway to make it in line. So you can see here right now there's no default route, but when I enable the functionality, it will then insert a default route and point it to the gateway. So let's go back over there. Let's do a discovery, because let's say we don't know really what our application is using, is trying to hit on the internet. So what we can do is under security, under egress control, we can enable the FQDN discovery function. So let's go find that gateway we just deployed, this one right here, and it'll enable on both the HA and the primary gateway. Let's hit start. So right now what it's doing is it's enabling the function on the gateway, but also reprogramming the route table to point the traffic to the FQDN gateway. All right, and it's done. It tells you what it enabled. So let's go and review that real quick. If we go back to that subnets, and if I refresh this, you'll see there's going to be a default route now pointing to the FQDN gateway for that private subnet. Bam, there it is. Default route pointing at the ENI of the Aviatrix gateway. Now what it actually does is it load balances the different availability zones across the different gateways I have available. So you can load balance. You can get a load share through both gateways, get higher throughput. If one of those gateways goes down, the controller will reprogram the routing to point to the available gateway, all automatically for you. So if we go back to the controller and do a show on the discovery process, we'll be able to see what FQDNs my app is trying to access. There we go, look at that. Right now, it's discovered that it's a Windows box and it's trying to access all these different FQDNs. You can download this and use it as a part of your policy. Next, let's log into that app, that Windows server, and make sure we can hit a bunch of stuff on the internet. So let's go here, and let's go to like CNN.com, let's go to eBay.com, and let's try PayPal.com. Okay, it looks like we can hit all these no problem. It's going to take a little bit of time to load those, but there we go. We can hit all of them. Fantastic. So unfettered, unblocked access to the internet. Now, what we're going to do is create a policy that only allows me to hit CNN.com and eBay.com, but nothing else. When I try to go to PayPal, it should be blocked. Okay, so let's close that out. And let's go back over here. Let's stop the discovery process because we don't need that running anymore. And we're going to create an FQDN filter. There we go. Now creating an FQDN filter is really simple. We do have a lot of knobs, a lot of features that you can enable and disable. And these knobs and features came to us through requests from our customers, from our hundreds of customers using this feature. And so there's a lot of functionality here. You may not need to use it all, but it's there when you do. So let's create a simple filter. Let's create a new tag. Let's call it allow some sites. I don't know, something random. There we go. Okay, now let's edit it and let's add some rules in here. So remember, we were going to allow CNN.com. Okay, that's fine. Hit save. We were going to allow eBay.com. Great. Hit save. Now you can see that this is a whitelist we're creating. So anything that's in here is going to be allowed. Everything else that's not specified in there is not allowed. Now you could do the opposite and allow everything but block only certain things that you specify, right? It's the opposite way of looking at things. We support both models. Also, we can do some wildcards in here. Let's do star.cnn.com. Let's allow that one. Let's do star.ebay.com. Save that. Okay, we're done. Let's just click update. Done. So it's updated that policy. But now we need to attach that tag or that policy to the gateway where our instances live. So click attach gateway. We're going to select the FQDN gateway. We're going to hit OK. And it's attached. Now the next step is to enable it. Right now it's disabled. You can have many different filters and some are enabled, some are disabled. But let's enable it now. So move the slider over, hit OK. Right now what it's doing is programming the gateway and also programming the VPC route table. Success, all done. Let's go test it out. So let's go back to my instance over here and let's open Chrome again. And let's try to go to, this Google thing was cached, don't worry about that. Let's try to go to ebay.com. That should work. Great, it works. Let's try to go to cnn.com. That should work. There we go, CNN loaded. Okay, and now let's try to go to paypal.com. That should be blocked because it's not on my whitelist. Yeah, it doesn't look like it's going anywhere. Let's try another site. Let's try reddit.com. Also blocked. So anything other than what I put in my whitelist, other than CNN.com or any component of CNN.com because I used that whitelist, or eBay or any component of eBay.com because I put that star in the whitelist, will not be allowed. Okay, pretty straightforward. Awesome feature, right? Now you could import, export these policies. You could attach the same policy to many gateways across your entire environment. It's modular. You can add, remove, edit. You can use different protocols. Remember, if I go back over here, you can specify TCP, UDP, ICMP, HTTPS, and the port. Pretty flexible. Here's a quick example of a real-world policy. You can see I have a bunch of different domain names, some with star dot, so I have a wildcard, but I also have IP addresses in here. If I scroll down, you can specify IP addresses and ranges to be match criteria as well. And you can specify a different port. In this case, it's 80 for this particular IP address, or you can specify the exact URL or FQDN. Let's say we wanted to pull some logs from our gateways. It's very straightforward. You select the gateway, hit actions, download the logs. It'll take a moment to package up the log. It'll get it for you. We can review it. Here are all the logs. What's been allowed, what's not allowed, what matches and hits it saw. It's awesome to have this at your fingertips the moment you need it to do some sort of troubleshooting. You can see that here. Fantastic. Now we can also export all these logs to Datadog and to any syslog mechanism, Splunk, etc. All that is supported. One other thing I want to show you all is the stats page. So after you've deployed FQDN filtering and you've waited a little bit of time, the controller will start to gather all the statistics and display it to you in a really easily digestible fashion. And so when you go to the FQDN stats section under security tab, you can see the aggregate stats as well as the per gateway stats. So aggregate stats is all the stats from all the gateways put together, presented to you. Per gateway stats allows you to see the FQDN filtering statistics on a per gateway basis. You can go in here and select the gateway. Now I only have two gateways, so there's only going to be two. The FQDN gateway and the FQDN gateway HA gateway, the one that I created for HA. So looking at the aggregate stats, you can hover over the different pie chart pieces here and get information about what FQDNs are being accepted and what FQDNs are being blocked. Now these are the top ones. You could have thousands and thousands, but what we're going to show you are the top ones. Same output for the per gateway stats. Quite nice to see this. You can go back in the last month, last week, or just from whatever happened today if you want to do that. Now if you want even more detailed stats, you can scroll down to the egress connection search page and you can now create filters to find exactly the accepted or blocked FQDNs based on more criteria. So you can specify the specific FQDN, the source IP, the start time, and the end time, and you can get information. So let's do that right now. Let's just do a quick search. If you scroll down now, you can see the log output of everything happening in that gateway. But if I wanted to filter it, I could filter it as well based on these criteria here. Now, there are a lot of features in the FQDN filtering solution from Aviatrix, so I recommend you go to the doc site and read through them if you're interested in this solution. Docs.aviatrix.com, go under the FQDN section and read all about the features that you can enable and disable. So just to recap, what we did in this demo today was deploy the FQDN gateways in a decentralized model. Every VPC or VNet that needs this functionality, you would deploy these gateways in. Now remember, there's also the centralized model that brings a lot of additional benefits. You get all the benefits of the Aviatrix multi-cloud networking platform when you leverage the FQDN filtering in a centralized model. I recommend you check out aviatrix.com to see everything else our platform offers. This is a full-blown cloud network platform that covers every corner of networking automation visibility in the cloud. So what did the Aviatrix multi-cloud networking platform do for us today? Well, it deployed the Aviatrix FQDN filtering gateways in a HA mode, high availability mode. It handled the configuration and the insertion of the gateways in the cloud. So the route tables and the subnets that needed to be inspected by the gateway were configured with routes to push the traffic through the Aviatrix gateways. It also provided advanced filtering policies. I showed you an example or a couple examples of that. Those are called tags. And lastly, it provided logging and visibility of the FQDN statistics. Anybody can pick up this solution and deploy it in minutes. It's incredibly easy, intuitive, and super powerful. I want to thank you for listening to me. I'll see you in the next one.